I'm sorry, I would take the screen up, but I never know. I assume it's perfectly set up for the operators. This is where the operators sit, and I never want to mess with their setup in case it drives it mad. So these are actually two regions in serpents that are star-forming regions that are currently. So this is one of the big things the JCMT looks at is cold gas and dust that's forming stars. So stars form in these dense clouds of molecular gas. It's really cold, and it just condenses down under gravitational pressure and forms new stars. And the JCMT can look at it before the new star has ignited and lit up. We can see this cold emission because it's so cold that it emits at our frequencies. If you want to give your spiel on that, because you've got a nice one.
Oh, the cold water, low temperature. So yeah, so this is the thing about really cold stuff, right? So you've all seen a poker held in a fire. It glows red, right? Let it cool down, it looks black. But if you point an infrared camera at it, you can still see it. It glows. We glow in infrared, right? Keep cooling things down. You stop glowing in infrared, and you start to glow in the submillimeter, lower energy radiation. And so this is why, when we're looking at submillimeter stuff, it's really cold. Therefore, our instruments have to be really, really cold so that they don't just basically blind our observations.
But most of what we look at is really cold things because they emit at our frequencies. And in fact, I'm pretty sure that, I don't entirely remember, but I think both of these two regions, these are quite bright nearby sources for us, but for optical people, this is a blank patch of sky. You don't see anything. You just see this little dark bit with, you can't see the stars behind. It's super boring. For us, it's really exciting.
Exactly.
So these are both, this is actually quite a cool project that's running at the moment that are monitoring for transient events in star-forming regions. So they try and look every 21 days, they do the same set of observations in the same regions. And they're running software in the background, which has to really get to an amazing calibration for what we do in submillimeter, to look for small changes that are temporarily varying. And what they're looking for is sort of explosive events in star forming, because star formation is actually quite dramatic. There's lots of bits being shot off, there's jets erupting and dying off and quiescent, and then you have planetary disks that are forming things and ejecting stuff.
So the other thing that's worth mentioning is that, some people say, why do we need a telescope on Maunakea, right? The reason that JCMT needs to be here is that it's really, really dry. We can observe through clouds that a lot of the other telescopes can't. We can observe in the daytime, which most of the telescopes can't. What we can't observe through is water vapor. It just basically kills our observations. So to give you a sense of how critical that is, if you take all the air from the top of the telescope all the way to the top of the atmosphere, you grabbed it, you condensed it down, and distilled out the water, if you've got more than 2 millimeters, we're done. It's got to be that dry.
Submillimeter observing basically needs a desert up a mountain, so there's as little atmosphere as you can get, and it has as little water as possible.
So that's why we need to be here, because there's almost no other place.
We can't build. You can't just pick a random mountain and build our telescope on it. We won't be able to see anything. It would be completely useless for scientific purposes.
Are there other places?
So I was trying to name the submillimeter sites earlier. There's the Atacama Desert in Chile.
South Pole.
The South Pole, but the South Pole you only see half the sky because it's at South Pole, and also the logistical challenges are immense for building anything there. There's Greenland, looks very promising, although there's again, I think, weather dependence over the years, so you don't have a whole year observing schedule the way you do here. And there's a possible place in Tibet, but there's both political issues.
The site testing has been taking place in the Himalayas, but it's also difficult. I mean, to get these kind of machinery up here and be able to not just build it, but keep it operating, you need power, you need cryogenics, you need people, you need trucks, you need fuel. It's just kind of crazy.
Maunakea is really special. Like, there are many places we can do this.
Oh, we've got people coming there.
Okay.
You want to talk about your pretty picture there for a second? Maybe put a perspective.